All right, today we're talking sets. As we can see here, looking at what a set is a collection of objects. A set is a list. A set can contain numbers, it can contain variables, it can contain letters or names. You can have a set of states, you could have a set of colors, you could have a set of specific numbers. A set is a collection of objects. Each object in a set is called an element. A set is named using a capital letters written with its elements listed within braces, not brackets, not parentheses, but braces. We can see some we can see some examples of sets. All right, they have objects in them. Here, set C. This is the pages in a chapter of a book. C equals, notice the braces, the numbers of those chapters. And notice when we do have numbers, we're listing them from least to greatest. Okay, so characteristics of a set, we have braces. If numbers, they go from least to greatest. Each object is separated by commas. Okay, just being really specific here. We have braces, least to greatest of its numbers, separate your objects with commas, no parentheses, no brackets, things like that. We have set A, students who made an A on a test. We just have these three names. If it's, I mean, you don't have to put those in alphabetical order. Are those even? No, they're not. Okay. So moving on here, L, the letters from A to H, A, B, C, D, E. I mean, they went alphabetical because it's just easier to read. It's easier to find. Letter G, we know where G is. It comes before H. N, positive odd numbers. Notice what they did here is kind of interesting. They used the braces, they used the comma, they ended with an ellipse right there to show it's going to continue this pattern. We know that we could not possibly list all of the positive odd numbers. That's going to go on forever to infinity. 13, 15, 17, 19, 21. We're going to go on forever. We don't have the ability to do that. So they used an ellipse to show we've established a pattern, and the ellipse says we're going to continue that pattern. Okay. Finally, it says to write that Olinda is an element of set A. We know Olinda is in set A. We use this symbol right here. That symbol says is an element of. That's what that symbol says. And we know that an element is each individual object. Olinda is an individual object of A. Olinda is an element of set A. So that is a true statement right there. We could say that 3 is an element of N. We could say that Karen is an element of A. We have a lot of ability to use that symbol right there that says is an element of. Okay, a lot of what we're doing right here, a lot of this seems very simple, and it is. We're trying to establish some really good, consistent use of these symbols that we might not be super familiar with, but yes, they are pretty easy. It's not trying to be difficult. All right, let's look at an example here. It says, use set notation to write the elements of each set, then determine whether the statement about each set is true or false. N is the set of whole numbers greater than 12 and less than 16. Okay? N equals, I'm going to use my brace. Okay? It's squiggly. It's not a parenthesis. It's not a squared off bracket. So we know it's a brace. Talking about a set greater than 12, that would be 13, 14, 15, but it's less than 16. It doesn't say it equals 12. Doesn't say it equals 16. Finally, is 15 an element of n? Yes, that is true. True statement there. V is the set of vowels. G is an element of V. Well, let's see. V is the set of vowels. So V, the set, A, E, I, O, U, sometimes Y, but not all the time Y. G is an element of V. G isn't an element. No. False. G is not in that set that we just established. M is the set of mouths that begin with mouths. M is the set of months. I read that incorrectly. M is the set of months that begin with J. M. See, J, we've got January. We've got June. We've got July. Am I missing any? January, February, March, April, May, June, July, August, September, October, November, December. I think those are what we got. Is April an element of M? No, that's false. Big false statement there. That is not true. X is the set of numbers on a die. Well, we know on a die we've got 1, 2, 3, 4, 5, 6. Is 4 an element of X? Yes, that is a true statement right there. That's true. Okay? Simple stuff. Let's carry on. When we talk about sets, I know we've all seen Venn diagrams before. We deal with Venn diagrams like in geometry and middle school and all kinds of different situations. But on a Venn diagram, each of those circles, each of those circle or oval or whatever grouping you have, that is representing a set. So when we write a Venn diagram, the entire world, the entire big squared off area, this is what we call our universal set. It says the universal set contains all elements within the rectangular. Okay, well, they have a universal set is a set of all possible elements of a situation. Okay, so if we're talking about numbers, maybe the universal set is real numbers. It's all possible real values. And then we could look at subsets of those real numbers. A subset is a more specific grouping. Here it says, if every element of set B is also in A. All the elements of B are also in A. So maybe A is whole numbers and B is just odd numbers. Well, A is all whole numbers, so it's 1, 2, 3, 4, 5, and so on. B is just 1, 3, 5. It's some of those numbers, not all of them. It's a subset. We do have a symbol for subset very similar to element. Subset symbol is this right here. B is a subset of A. It's kind of like a U on its side. B is a subset of A. That would be true. B is a subset of A. Because we can see all of B is contained in A. Finally, we do have one more vocabulary on this. It says complement. Complement essentially means the opposite. If we want to talk about the opposite of B, we would put a little apostrophe right there. They wrote right here, B apostrophe. The complement of B, the opposite of B, would be everything outside of B. If we're talking about here is B, the complement is going to be all of the stuff outside of B. There's the complement of B right there. It's the opposite. It's everything outside. Still in the universal set, but outside of B. Let's move on. Okay, we've been given these lists. Notice here, U, our universal set. This is the group of all the numbers we're working with. This is everything. This is everything we're working with right here. We've got U. First it says, is B a subset of A, true or false? Well, in order for B to be a subset of A, everything in B has to be in A. B is 5 and 7. Looking there on A, 5 and 7 are part of A, so this is true. That is true. Next, is E a subset of D? Well, here's E, 6 and 3. In order for it to be a subset, both of those have to be in the set of D. Well, since E has 6 and 3, here we don't have 6. This is false, because all of E is not contained in D. Find the complement of A. Well, the complement of A is going to be everything not in A, but still in the universal set. So that would be like 0. 0 is not in A, but it is in the universal set. 2, 3, 5, 7, 6 is also not in A, but in the universal set. And we want to find the complement of D. Again, the complement is going to be everything not in D, but contained in the universal set. It is the opposite of D. So that would be 0, 1. D only contains 2, 3. So the complement is going to have 4, 5, 6, 7, 8, and 9. Cool. And of course, we've talked about we've talked about union, intersection, things like that. I know you talk about that in geometry, so we use those same terms when we're talking about sets in this class also. The union is written with kind of it's a U-looking shape. Union is when we bring together everything of those two sets. We're uniting these two sets into one. Union, bringing it all together. Intersection, on the other hand, kind of the upside down U, it's written right there. Intersection is the overlap. What is in both of these? If it's not in both, then it's not going to be in the intersection. The union brings together everything. The intersection is what they have in common. Union, everything, intersection is what they have in common, where they have overlap. Sometimes we're going to have to use the empty set. The empty set is where we have no overlap. There is nothing in common. There is nothing in a set. And there's two ways to write empty set. You have a 0 with a line through it, or you can literally show a set with no elements. We're given U, R, S, and T. First, we want to find R union S. We know that a union is bringing together everything from R and everything from S. So that's going to be 2. Notice they both have a 4, but we only have to write it once. We've got a 5. They both have a 6, but we only have to write it once. And we have a 7. So there's an important thing about sets. Duplicate numbers in a set only have to be written once. Okay, so we've talked about set. Braces, numbers from least to greatest, separated with commas, and we only have to write each object once. Even if we see it's twice, there's a 4 here, there's a 4 here, we only write it once. Here we want to know the intersection of R and S. What do they have in common? What is the intersection of R and S? Well, we notice they both have a 4, and we notice they both have a 6. What they have in common is their intersection. Finally, what is the intersection of T and S? Well, T just has a 1. S doesn't have a 1 at all. there is nothing in common. There is no overlap. There is no intersection. So we say it's the empty set. It's not 0. Okay? These are your options for the answer. Empty set, written 2 different ways. Here is not correct answers for this. Not correct answers. 0. None. Nothing. That's not what we're looking for. The answer is a set. These are not giving a set. These are your 2 answers. So, again, not crazy stuff. Hopefully this helps just make a lot more sense out of these things.